This morning in the Atlanta airport, no one's missing a meal on Mac Wilburn's watch. With 11 restaurants to serve passengers, he's got dining for every destination. And it all started when Mac talked with First Horizon Bank about opening a franchise in the airport. Now it's open for business and cleared for takeoff. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac. First Horizon Bank, member FDIC.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on Space Nuts, episode 115. And joining me as always, astronomer Fred Watson. Hi, Fred.
Hi, Andrew. That feels like my age at the moment.
I wasn't going there. Actually, I probably would have.
No. You don't need to. I do it on my own.
How you been?
Yeah, very well, thank you. All good.
Good.
Despite being 115 years old.
You look great. You don't look a day over 114, to be honest.
Yes. Ladies and gentlemen, this is what I have to put up with every week.
Yes. For more years than we care to remember.
Yeah, that's right. That's all right.
Well,
and hopefully more to come.
And Fred can't remember them. Now, today we're going to look at something very exciting that NASA has announced. They'll be doing the first all-US space launch since 2011, which is very exciting news. That'll happen next year, but they've basically rolled the crew out. And explosive evidence of a star bounces back to Earth, and they're taking advantage of that opportunity, which is a little bit complicated, but I actually understood the article when I read it, so Fred will be able to tell you more about that. And Richard Goodman, our mega question asker of last week. We've got part 2 of Richard's question about gravity versus dark energy. Which is another complicated matter that Fred will have no trouble deciphering. So, Fred, let's start with this all-US launch that's been touted for possibly April, the first all-US mission since 2011.
That's correct, Andrew. So this is pretty exciting, I think, for everybody. Of course, the space shuttle retired back in 2011. The last flight was by the Space Shuttle Atlantis, and there have been no US-launched astronaut missions since then. All the astronauts who've been ferried up and down to crew the International Space Station, and that happens pretty regularly, they've been carried up there by Soyuz spacecraft of Roscosmos, the Russian space agency. And the Soyuz, well, a workhorse of human spaceflight since the 1960s when they were developed, but it is time for new technology. And the shuttle, it was the right decision to retire the shuttle. What happened was NASA at that point decided that what they wanted to do was basically buy launch services or ferry services for astronauts so they could concentrate on really cool stuff like building spacecraft to take people to Mars and things of that sort. So that's what's happened. And there are 2 main agencies or companies who have provided the capsules, and they're both well established. Their technology is well tried. Both have launched many times, just cargo spacecraft up to the International Space Station using the same technology. But as you said, next year, these 2 companies will basically send the first space flights up to the shuttle with astronauts on board. So the reason why this is a big story is because of that, but also that the sort of cadre of astronauts who will take those missions has been announced. There are 9 of them. And I think I'm right in saying that all but 3 have flown before. And in fact, some of them were on the final shuttle mission. There's a whole range of different experiences, but most of these people have been in orbit. I think there are 3 newbies, and I'm sure they will meet up with the standards that are required. They're not all men. There's a couple of women among them as well, which is great stuff. So the technology, or the actual technology that we're dealing with here, two companies, SpaceX and Boeing. Boeing have been working on their capsule, which is called Starliner, and Starliner will also form part of the planned possible missions to Mars. So Starliner will, I believe, make its first crewed flight in the middle of next year. They haven't quite yet fixed the date, whereas I was going to say the opposition, but I don't think they are the opposition. These companies have worked pretty closely together, even though they are quite independent, and their spacecraft are quite different in appearance because they've been designed for different things. SpaceX, of course, Elon Musk's company, often in the news. Their capsule, which is called Dragon, has been used many times to take things up and down to the International Space Station. But in April next year, possibly before Boeing's first flight, in April they will take their first crew up to the International Space Station. And probably both of these flights will probably be fairly short-lived, just to try the technology, make sure everything works before there are proper ferry services up and down to the space station, which is really what this is all about.
Yeah, I suppose it's a bit like a back to the egg scenario, like the Apollo missions. The first few of those were just a few laps around the planet, and then they ventured out further, and then Apollo 8 did that famous lap around the moon. I think it was 8, and then
it was Apollo 8. Look, that was one of the highlights of my life at that time. It was they orbited the moon on Christmas Day, 1968.
That's right.
Took amazing photographs. Yeah,
and of course, then that culminated in the famous landing of Apollo 11, which is nearly 50 years now, coming up on 50 years next year.
It will be. Correct.
Which is very exciting, and so this is sort of the same deal. They're just going to test this gear out, send a few people up, have them sort of float around for a couple of days, and then bring them back. And ultimately, once they've ironed out any bugs or issues, they'll be ready for business.
I think that is the case, and it's exciting stuff, as I said, because certainly the Starliner, Boeing's spacecraft, is destined for service on long-haul missions, which means Mars, and possibly with a return to the moon before that. So this is, I think, we're opening up a new pathway in human space exploration, which is very exciting and involves the commercial sector. That's the big difference between this and what happened before. I mean, companies like Boeing were certainly involved with the lunar landings, but it was all very much under NASA's control. It wasn't just a service that you can buy, which is what they're aiming for now. Yeah,
and I suppose it wasn't really feasible long term for governments to bankroll these things. It had to go private ultimately, didn't it?
Yeah, that's right. Indeed, that's right.
And there's probably money to be made eventually in some form or another. I mean, it's got to be a profitable venture. Otherwise, it's just never going to work.
That's right. And there are all kinds of prospects. There's tourism is one.
Yep.
The mining asteroids and possibly the moon is another. All of these things are things that could potentially make money. It's long-term stuff, though. It's not the there's not going to be huge profits the day after tomorrow.
Well, as we've previously discussed, something like mining the moon or asteroids is probably 100 years away. It's not, but they have to do the groundwork now to make it feasible in 100 years' time. If we don't start now, then it will take another 100 years if we wait 100 years. So,
Actually, I don't know. I don't know to what extent that is absolutely going to happen, and a lot depends on what these asteroids are made of. But I bet it's less a smaller timescale than that, Andrew. I think we're more like 20, 30 years, something like that.
It's still a long way off, but yes.
It's a long way off,
They've got to
It's when you're 115, I can tell you.
Yes, indeed. And of course, they're talking about this American launch in April, so we will watch and hope that they're running on time and that all is well. And these companies have been successful getting up and down most of the time, which is even better.
That's right, exactly.
All right, we'll keep an eye on that one. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new, new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Next up, Fred, we're going to look at an explosion that happened about 170 years ago. What's really interesting is that we can still see it because the effects of that explosion have bounced back, and astronomers today are now being in a position to analyse that data, which is quite amazing. But what's the story behind this original explosion? Something weird happened from what I understand.
That's correct, Andrew. This is really a story about a very, very special star. It's called Eta Carinae. It's in the southern sky, not very far from the Southern Cross, in fact, for those who can see the Southern Cross. It's in terms of its absolute brightness, that means, its intrinsic brightness, it's actually the brightest star we know of in the galaxy.
Is that right?
Yeah, and back in it was the late 1830s, but that it started getting brighter and peaked in, I think, 1843. It peaked in brightness. Of course, astronomers were observing it without really understanding what was going on, but it got to be the second brightest star in the sky after the bright star Sirius, which is still the brightest star, and then started fading away. So 1843 or thereabouts, it was brighter than, in fact, its brightness was about 6 million times the brightn's of the sun. So,
really? Wow.
Yeah, it's not, we're not talking about, it's a little bit brighter. It was 6 million times brighter. It's a phenomenal object. So the story then goes, I guess, forward throughout the 20th century, when this object was observed photographically and eventually with the spectrograph, the instrument that analyzes the light from target stars and galaxies. And we now know, particularly from Hubble Space Telescope pictures, that this star has produced outbursts of material which are glowing quite brightly in a nebula cloud of gas around the star itself. And in fact, even with a modest-sized telescope, I suppose a relatively small amateur telescope, not something that most people would have. It would be rather the province of amateur astronomers. But even with a telescope like that, looking through it, you can see this kind of orange glow, which is the nebula that is being illuminated. Back in the 1970s, a friend of mine who sadly is no longer with us, who was a great astronomer and a great popularizer of astronomy, David Allen, his name was. His name is enshrined now in the David Allen Prize, which is an award for science outreach by the Astronomical Society of Australia. He was one of the first to speculate that this object was actually a double star. It was two stars interacting with one another. Okay. And that's somehow that interaction produced the colossal energy. But nobody could really work out, and certainly David couldn't back in the 1970s, why it went through this massive outburst period in the 1830s. So, 170 years ago from where we stand now. But exactly as you've said, the modern technology has come to the rescue, because we now have telescopes and instruments that are sensitive enough not only to see the direct light from an object like this, but also to see the reflection of its light off nearby dust clouds. And while those dust clouds are nearby, relatively speaking, they're far enough away that they put the light travel time, because it takes a dogleg path, is 170 years. So the direct light is, what we see. But if you put a dogleg in the path by reflecting that light off a dust cloud, then, as has happened now, that allows you to see back exactly what was going on 170 years ago, because the light travel time has been increased by 170 years. You're looking puzzled.
No,
Andrew.
I'm not. I'm just thinking of the situation. So you've witnessed the event with direct path of light.
Exactly.
And because the light travels out in all directions.
All directions, yeah.
Some of it has bounced off something like a cloud and then hit Earth, and it's travelled almost twice the distance or thereabouts or whatever.
Well, in fact, yeah, that's right, or whatever, yeah. Actually, I should say this thing is about, I think it's around about 6,000 light years away.
Wow.
So what you do, so it's already, the light that you see directly is taking 6,000 years to get here. This dogleg path that is taken because light reflects off a nebula is only adding 170 years to that, but it's enough to let you see the outburst. I think this is an almost magical technique, and it's been used a lot. And David Allen actually was one of the pioneers of this type of observation back in with supernova 1987A. It's called a light echo. And in fact, I've been writing about it recently for a new book that I'm working on, because I think it's just sensational that you can look at something and see the same light as was seen, hundreds of years ago, but it's taken this long way round, and you can now analyze it with the equipment that we've got today.
That's
and so
amazing.
It's spectacular. I think what I'm hanging out for, and I'm sure this will happen, there was an exploding star that created something we call the Crab Nebula, which is in the constellation of Taurus.
Yep.
And that star exploded in 1054. It was witnessed by Chinese astronomers. But I bet within the next 5 years, there will be new telescopes which can actually see the light echo from that. And that will allow astronomers to analyze the light that was being produced when this thing exploded.
So this suggests that light from various events in history is still bouncing around out there, and
exactly,
who knows what we can find.
Exactly right. It's all, the universe is full of these echoes. But back to Eta Carinae,
yes.
What's happened is the light echo has been observed. So we've seen the light that it was emitting when it was at its peak back in 1843. And guess what? It tells you that there's almost certainly a third star in that system.
A third star?
That collided with the big bloated star, basically was gobbled up, and the explosion sent out a shockwave which interacted with the material around it and produced this massive increase in brightness. So it's a wonderful piece of detective work using this light echo technique, which I think is just great.
It's incredible. And you just can't get your head around the cataclysmic awesomeness of two stars colliding. I mean, that's just, I can't think of any way of describing something at that magnitude, it just, imagine being close by to witness that. You probably wouldn't last, but
Well, you wouldn't know. That's right.
it would be an amazing spectacle.
Yeah, indeed. And this star, it is the larger component of the star is very unstable and is massive, and almost certainly will wind up as a supernova, a star that explodes, like the one in 1054. That will produce an explosion that would be very spectacular, almost certainly visible in the daytime sky. It would be so bright. It would release clouds of neutrinos and other subatomic particles. Hopefully, we would be we're far enough away from it at 6,000 or 7,000. It's not quite clear where it is, but it's probably 6,000 light years or thereabouts. Far enough away from it that we won't be fried, but it would still be a spectacular event.
Absolutely. It also demonstrates how the sky, as we know it, changes. It changes all the time, and it sometimes changes rapidly. So what we're seeing today would, even 170 years ago, not be quite the same because of events in the astronomical history. It is fascinating.
Yeah. One final thing about this, Andrew, is that the explosion of that star 170 years ago found its way into Dreamtime stories. There are Aboriginal peoples who talk about it still in the narrative. So it's fantastic stuff.
Yeah, it is indeed. All right. Well, and given that the technology exists now for us to look at these light echoes, we who knows what we're going to find next? It could be really interesting.
Watch this space.
Literally. You're listening to Space Nuts with Fred Watson and Andrew Dunkley.
0G, and I feel fine.
Space Nuts.
Righto, Fred, time for a question. And we're actually going to finish off a question from Richard Goodman, who messaged us a week or two ago about the moons of Jupiter and a couple of other things. But he's asked another question in the same narrative, which we're going to tackle this week. And it's about universal expansion. And I'll read this out in its entirety, and we'll see if we can lose everybody in the process. I understand, sort of, that the expansion of the universe is tiny on the local scale, but massive on the truly enormous scale. Is the expansion due to dark energy negated by gravity, or does it not exist where there is another force to prevent it? If it's negated, then is the gravitational constant ever so slightly stronger than we've always thought because it's overcoming the expansion that wasn't considered before? If dark energy doesn't exist where gravity rules, what are the thoughts on why? And finally, if you had two Milky Way-sized galaxies, how far apart would they have to be before dark energy took over and gravity would never bring them together? Answer in 10 seconds or less.
Well, no and yes are the answers. Look, it's a great question. Let's do the last bit first. If you had two Milky Way galaxy-sized objects, how far apart would they have to be before dark energy took over?
That sounds like something you'd have in a science test. That question.
It does. Yes, that's right.
And my answer would be about that much.
Yeah. That's correct. I think the important thing here is to, first of all, forget about dark energy for a few minutes, because when we observe the universe, one of the easiest things to observe now with the technology that we've got is that the universe is expanding. That was discovered, of course, back in 1929 by Edwin Hubble. And that expansion is something that we can measure from the vantage point we have now. In other words, we can deduce something, we call it H naught, in fact, the Hubble constant, which is the rate of expansion here and now. And so that gives you a first clue about the fact the universe is expanding. Now, it's actually very hard to look in enough detail to see how that expansion has behaved over the past, but you can do it. So from Hubble's time until probably the late 1980s, People knew that the universe was expanding, but they speculated that because the universe is full of stuff, it's full of galaxies, stars, planets, space nuts, all of that is in the universe. All that stuff has gravity, except space nuts, which is the least.
Very lightweight.
Gravitas is not part of our. Anyway, so the universe is full of material. So we expected that would have a braking effect on the expansion, that the gravitational pull of all the objects in it would slow things down. Not so, because in 1998, the discovery was made that if you make careful enough observations that sort of track what the expansion has been doing over the last 4 or 5 billion years, remember the universe is about 13.8 billion years old, that gives you a different answer. It tells you that the expansion is accelerating. So far from slowing down because of gravity, the thing's whizzing further and further apart. And we glibly give the name of whatever causes that acceleration, we call it dark energy. It's measured by a parameter called W, which is called the equation of state, which is basically the ratio of the gravitational pull to the expansion pressure, and that's the technical part of it that we don't need to discuss. The really interesting bit is where does this accelerating expansion come from? We believe that the expansion itself comes from the initial Big Bang, that set in motion an expansion of the universe, a kind of explosion, which is still going on. But what's causing it to accelerate has a different source. And it's not to do with gravity. Gravity exists between objects, so it's matter that causes gravity. Dark energy is a property of space itself. If you took everything out of the universe, it would still be there.
Yeah.
And to the best of our understanding, the amount of dark energy is directly proportional to the volume of the space. So that as the space expands, the volume gets bigger and the dark energy gets bigger and the expansion continues to accelerate. So it's a process that is, self-propelling in a sense. It's getting more and more expansion. That's because we can, by making very careful measurements, we can detect this effect that the expansion, the dark energy, the energy of space, seems to be proportional to the size of space. It's a difficult measurement that's taken a long time to come out, but that is basically the status quo at the moment. So it's not to do with the gravitational constant that works with gravity, and that's quite specific. Dark energy is unrelated to that. And it's a mystery. We don't know what causes it. But just going back to finish what I started at the beginning of this, if you had two Milky Way galaxy-sized objects, how far apart would they have to be before actually not dark energy took over, but simply the expansion of the universe, and gravity would never bring them together? I don't know the answer to that. It would be measured, I would guess, in probably tens of millions of light years. So our nearest big neighbor galaxy is the Andromeda Galaxy. It's about the same size as the Milky Way, possibly a bit bigger. It's 2.5 million light years away. But the Andromeda Galaxy and our galaxy are on a collision course. They're coming together under their own gravitational pull. If they were 100 million light years apart, that wouldn't be happening.
Yeah.
So I don't know what the upper limit is, but
we don't know what the minimum threshold is.
Well, we probably do. If I looked it up, I could probably find it, because there will be a number, and it's related to the Hubble constant that I mentioned before. Yeah. What distance does gravity get completely overcome by the expansion of the universe? It will be tens or possibly hundreds of light years. I think tens of millions, I beg your pardon, or possibly hundreds of millions of light years.
Okay, Richard, there's the answer to part 2 of your 3,000th question to us. Did we answer the first part about the dark energy issue? I know we talked a lot about it, but I completely got lost.
Yes, we did.
Okay, good. What was the answer?
The answer is it's nothing to do with gravity.
That's right, yes. I knew. I picked that up in the translation somewhere, but it fell out of my
Pay attention,
universal
Andrew.
void of a brain. Yeah. Okay. I was trying to pay attention, Fred, but I suppose we should sort of applaud Richard because they were extremely intelligent and well-constructed questions, and they really do make you think. And unfortunately, that's something my brain refuses to do a lot of the time. So.
It had not escaped our attention.
Yes, indeed. All right. Thank you, Richard. We do appreciate your questions. I think we got through all of them. And we certainly invite your questions. We're getting plenty of them. I'm working on a way of perhaps consolidating so we can send you to one place to ask your questions so we get them all together, because it's a bit of a hodgepodge at the moment, and sometimes they're just going through to the keeper, which doesn't help you. We don't answer them all. Some of them we just can't get to, or they're just way too hard for us, or they're just too easy. But we do our very best. But we do appreciate your feedback and your support of our program indeed. So thank you, and do keep them coming in. And thank you, Fred, as always.
It's a pleasure, Andrew. It's great to have the mind stretched by all these, as you said, absolutely intelligent questions from the people who listen to Space Nuts. I'm very thrilled with it.
Yes,
thank you again.
Me too. All right, we'll talk to you next time.
Sounds great. See you later.
Astronomer Fred Watson on Space Nuts, and we thank you again for listening. And don't forget to tell your friends and follow us on Facebook or Twitter or any of those social media platforms. And we will talk to you again next time on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.